Here we are at our target 3C from our Chapter 5 study guide. We're asked to state the horizontal asymptote, state the domain range, and then determine if this thing is increasing or decreasing while graphing this. Now, in just looking at it, what we're going to go ahead and do first is identify what is our A, B, and our horizontal asymptote. So this -2, because it comes first, it is our A value. This thing inside the parentheses with the exponent, that would be our base, B. And lastly, our horizontal asymptote is this 3. Now, you can rewrite these in different orders, but as long as you can identify that this number right next to the base with the exponent, that would be considered our A value. And any kind of number that's kind of like added or subtracted would be our horizontal asymptote. So in other words, what I mean is that this horizontal asymptote could really be in front and this part is behind it. So, but again, this is our exponential function, and just stating the horizontal asymptote, we can go ahead and do that pretty much right away. So our horizontal asymptote, again, is that electrical fence that we can't cross. So in this case, it is y equals +3. Next, we want to go ahead and state the domain and range, but to do that, we need to kind of graph this. Actually, really, because it is an exponential function, the domain is pretty quick and clear-cut. We are talking about an exponential function again, so our domain for those is always from -infinity to +3. That will always be true. Now, in order to find the range, what we're going to do is graph. And to graph this, we're obviously going to need to make an XY table. So here is our XY table. Just kind of thinking ahead, we want nice exponents that make our life a little easier. We know that anytime we have a 0 for that exponent, that's going to make our lives a little bit easier. So in order to get that, we would have to throw in -1 in here. So we'll definitely throw in -1. We can also throw in 0 to have, when we add 1, anything raised to the first power. That's a nice easy 1. So we'll also throw in 0. And then we could throw in like 1 and 2. Just kind of see what those y values come out. When we throw in -1, we end up with y equals -2 times that base 4 raised to the -1 plus 1 plus 3. Simplifying things up, we end up with y equals -2 times that base 4 raised to the 0 power plus 3. But anything raised to the 0 power, as we've said, is just 1. So we end up with -2 times 1 plus 3. So -2 times 1 comes out to be -2 plus 3. So then y is equal to then just 1. So at -1, we ended up with the y value regular 1. Next, going ahead and dumping in 0, we end up with y equals -2 times that base 4 raised to the 0 plus 1 plus 3. So then y is equal to -2 times our base 4 raised to the 0 plus 1 is 1 plus 3. Anything raised to the first power like this is just that base. So we have 4 times -2, well, that's -8 plus 3. So it looks like our y value comes out to be -5. So at 0, we end up with the y value of -5. We'll go ahead and plug in now +1. So y is equal to -2 times the base 4 raised to the 1 plus 1 plus 3. Again, just plugging that value in for x. Giving us then y is equal to -2 raised to the, times 4 raised to the second power plus 3. We combine these exponents. So y is equal to -2 times 4 squared is 16 plus 3. So it looks like y is equal to -2 times 16 is -32 plus 3. Well, that'll give us -29 for the y. So 1 comma -29. 29. If we were to keep going with this exponent 2, we would end up with a very, very big negative. Obviously, we can kind of see it getting very, very big in terms of the negative solution. So let's go ahead and change this then to a negative 2. Again, sometimes you might need to adapt just depending on the values that you're ending up with. So we'll go ahead and change this then to a negative 2. Plugging negative 2 in there, we end up with y equals negative 2 times the base 4 raised to the negative 2 plus 1 plus 3. So then we end up with y equals our a value negative 2 times the base 4 raised to the negative 2 plus 1 is negative 1 plus 3. But since we can't have negative exponents, we're going to rewrite this forward to the negative 1 as 1 over that base 4 raised now to the positive 1 plus 3. Negative 2 times a fourth gives us negative 2/4 or negative 1/2 plus 3. And then lastly, negative 1/2 plus 3 would give us a y value of 2 1/2. So at negative 2, we end up with the y value 2 1/2. Going ahead now and plotting these, we end up with negative 1 1. And right about here. For the green one, we ended up with 0 negative 5. And right about here. At 1, we ended up with the y value negative 29. Which we know is going to be down here somewhere. And then our last value, negative 2, 2 1/2. Right about here. Going ahead and connecting these, we would see something like this. Now, in just looking at our horizontal asymptote, we know that our electrical fence is occurring at 3. So we do have that electrical fence that has to kind of border, but not quite touch. So then looking at our graph, we notice that it's going to curve and just kind of hover that horizontal asymptote. So our graph looks more or less like this. So again, the domain is always pretty clear cut. The range is really the one that varies for exponential functions. So when we're discussing our range, we always work from the bottom and go up. So it looks like the smallest thing that y values can be here. Notice how this arrow is going toward negative infinity. That would be our smallest y value that we can end up with, negative infinity. And then it's kind of just going up along the graph, and then it caps out at that horizontal asymptote of 3. But since we can't actually obtain that electrical fence, we end up with a parenthesis around the 3 as well. Now, is this increasing or decreasing? Obviously, it is going downwards as x is increased, so this would be a decreasing event. We can see that the arrows are going downward, again, decreasing. Again, though, that is target 3C from our Chapter 5 study guide.